Good afternoon, class. Today we're going to be working with section 3.8, which has to do with the union and intersection of sets. So if we remember from section 3.5, I think it was, we talked about sets just being a list of items, sometimes numbers, sometimes letters, or objects. So we're going to take and figure out what the union and intersection of those sets are. The union of two or more sets is the set that contains all the elements in that set. So if we're working with a set, the union is just going to be a list of everything in both sets. The intersection of the two sets, if you think about the intersection of a road, an intersection of a road is where two roads cross and they have that pavement in common. Well, that's similar in sets. We're looking at where two sets would have two things that are common or the same. When we're talking about the union, we're going to use the letter U to represent the union of two sets. So that's a symbol that you should be familiar with and you're going to see. An upside down U is going to represent the intersection. So those are two symbols that we will use. Instead of writing the word union and intersection, we'll use those. So if we talk about the set that contains penny, nickel, and dime, and then the set that contains B that contains nickel, dime, and quarter, the union of these two sets would be combining these two sets and listing them in one. Now you'll notice that there are a couple that are the same. Nickel and dime are in both, so we only list those once. So when we go to list the union, we would say it's penny, nickel, dime, and quarter. The nickel and dime consists of, exists in both, so we just list it once. That helps us determine what our intersection is. The intersection is what they have in common, and that nickel and dime that we did not list over here twice would be listed as the intersection because they have those two things in common. So let's talk about the set D, which involves cheese, milk, and yogurt, and then the set F, which consists of apple, banana, and pear. The set down here that's being described, apple, banana, cheese, milk, pear, and yogurt, would you say that would be the union of those two sets from above? So I'm just going to write in here union. That's what we're being asked to pick. We're asked to pick union and intersection. The set D now becomes cheese, milk, and yogurt, and M becomes bread, cheese, and egg. And if we allow the set cheese to be the described set, we would say that that's the intersection. That's what they have in common. If we look at this, they both have cheese in theirs. That's the only thing they have in common. So we're just going to say that the intersection is the result set down here. Down here we have apple, banana, and pear. And then here we have bread, cheese, and egg. Well, the empty set is described as the intersection because they have nothing in common. So we're just going to say the intersection, in this case, is the empty set. And if you remember from section 3.5, empty set sometimes is denoted as the set symbol with nothing in it. So that's the empty set. So let's talk about two sets being described in a different form. This is not roster form like the other ones were. We're going to give you a set P, which is the whole numbers less than 5. And Q is going to be the even natural numbers less than 5. So let's list these in roster form first. So P, we're going to let that be the whole numbers less than 5. So 0, 1, 2, 3, and 4, and we're not going to list 5 because it didn't say equal to, it said less than. Q is going to be the natural numbers, so those are like the counting numbers, less than 5. So 2 would be the first even natural number, 4 would be the next one, and then we would stop. So if we want to know what the union of these two sets are, so P union Q, we would say that 0, 1, 2, 3, and 4 would be the union. It basically is P because 2 and 4 are in common. So the union sometimes will be one entire set depending on what they have in common. Let's talk about some intersection. Here's a set A, 2, 4, 6, 8, and set B, which is going to be 0, 2, 5, 7, and 8. And then C is going to be N being an odd whole number. So before I start talking about what we're dealing with, let's just identify this to be the intersection symbol. That's what we're going to be dealing with. And what they want us to find is what is A intersection B? Well, A intersection B would be the set that contains the common things. So I'm just going to go through here and circle the things that they have in common. So they definitely both have a 2, and they both have an 8. So 2, 8 would be the intersection of those two sets. Down here we're going to deal with A and C. Well, before I start working with C, let's just list out C in roster form. We're talking about the odd whole numbers. So 1, 3, 5, 7, 9, and then it just keeps going in that form. So if we wanted to know A intersection C, well, A has no odd numbers. So it will not have anything from C in it. So this would be considered the empty set. Okay. C intersection B, so we're looking for odd numbers that might be up here in B, and 5 and 7 are both odd, and 5 and 7 are both in here, so 5 and 7 would be the intersection of C and B. So we're looking things in common. Now we're going to be dealing with some Venn diagrams. We talked a little bit about this in section 3.5. Venn diagrams are just circles, and we fill in those circles with items from sets. So if we're talking about letting A be one of the first 5 letters in the English alphabet, so I'm going to list that in roster form down here. So let's just list out A, B, C, D, and E. Those are the first 5 letters of the alphabet. Set B is going to be the vowels, A, E, I, O, and U. And since we're not talking about sometimes, we want all vowels, we're not going to list Y. So here are your vowels. C is going to be the letters in the word vegetable. So we have a V already listed here, E, G. Now we already have an E, so we don't need to list that one again. T, A, B, L, and there's already an E listed. So these letters down here represent all the letters in the word vegetable, not writing any repeated letters. So which letters are in all 3 sets? Well, that would be, and there's some notation that we can use for this, it would be the intersection of all 3 sets. So the intersection of all 3 sets, there is an A in all 3 sets. So we would list that down here. There is no B because the vowels don't have B in them. No C in all of them, and no D in all of them, but there is an E in all of them. So A and E would be considered the intersection of all 3 sets. So that's what's listed in all of them. So what we're going to do is we're going to write this in a Venn diagram down here. I'm going to move this Venn diagram up, and we're going to fill in the information that goes in here. So the first thing we're going to do is put in here A and E will be where all 3 circles intersect, because that would be considered the intersection. Set B and C have A in common, but it's already listed here, so that's already included, and they have no other things in common. A and C have A and E in common, so we would just list those there, but they also have a B in common. There's a B in set C, and there's a B in set A, so B would go here where A and C's circles overlap, but don't overlap with B. So in this case, these intersecting circles, we're just listing the things that they have in common when they intersect. So now what we're going to do is list over here in A the things that are not listed in here. So we have A, we have B, there's no C in the intersection, so C no D, so that goes out here. So the letters C and D will only be in A's circle and not in any overlapped circle. Set B up here, we already have A, we already have E, then we're going to have I, O, and U, and set B only out here by themselves. And then the word vegetable is going to have the V, E is already there, G, we need to put a T, A is already there, B is already there, and L. So V, G, T, sorry about that T there, and L will only be in the set C down here. So this representation allows us to write a Venn diagram describing all three sets put together. And we'll use Venn diagrams in some of your classwork. All right, we're going to do one more Venn diagram here, and we're going to do it from a description of an item. So we're going to have to list some things that are in the set, and then we'll work from there. So we have 30 total students. So when we're done with our Venn diagram, the numbers that are represented in here should be 30. There are 20 that are honor students. So in this big circle here, we should have a total of 20 students. And then there are 9 that are officers and honor students. So we know what number goes in here. The intersection of the two sets is 9. We know that they both consist of 9 students. There are 9 that are officers over here, and then there are 9 that are honor students. And there are a total of 30 in all of them. All of the students are officers, honor students, or both. So how many are officers but not honor students? So we need to figure out here how many are going to be over here in this circle by themselves and not part of the honor student group. So we will start with filling in. We're going to let H be the honor students, and we're going to let O be the officers. So the intersection, as we stated, is 9 because we know that they share those items. So only honor students would be taking the 20 that we know are honor students and subtracting the 9 that are shared. So that gives us 11 honor students. So 11 would go here. We know there's 11 honor students. So those that are only officers, if we take the 30 total students and subtract the 20 that we know were honor students, that's going to leave us with 10 officers. So that answers our questions. There are 10 that are only officers. So those are the non-honor students. So we just did that by pulling information away. We certainly could have done this without a Venn diagram, just using our information from above. But the Venn diagram helps you to kind of understand where they overlap and where they don't overlap. So you'll answer some questions after the video, and then you will come to class with any questions and your notes, and we will do some classwork.